In this project, we're going to take a comprehensive look at energy loss in a building and specifically do a little bit of analysis. In this case, it's going to be an analysis between two window systems. And what we have here is a project parameter set up in the green box here. All of this is done on a spreadsheet. I'm sorry I didn't indicate that at the beginning. This is a Google Doc spreadsheet, and I will show you how to set that up in some of the following videos. But in this case, the project parameters are all of the things that we've learned in the prerequisite lecture for this course, or for this class and project. How we come up with the R value of a wall system and then turn it into a U value. We're going to use two different U values for windows so that we can run two different scenarios. We add a roof system in. I leave the floor system out because it's a little bit more complicated in calculating heat loss. But we do look at air infiltration, so we talk about how tight we've constructed the building, and we put in a value for that. A design temperature, we gather heating degree days, and we do that by looking them up for our location. And we can download a spreadsheet. We can actually include that spreadsheet and get our total heating degree days for our building. And then we need to know some basic ideas about the construction of our building. And what we're going to do is at the same time simultaneously run the same calculation inside of our BIM model or Revit. And so if I was to open that up, it will automatically do heating and cooling loads also. And I'll just show you what the model looks like here. It's a very simple model. It's a 20 foot by 20 foot by 10 foot high building. We make some specific walls and window systems. And those window and wall systems have R values to them also. And we're going to learn how to create a BIM. And I just opened a window and I need to drag it over. We're going to create a structural system that gives us a calculatable R value for that wall assembly. If I was to go in here and edit that, you can see how we'll be able to add in materials to create an insulating composite wall system. So let's not get too far ahead of ourselves here. I want to jump back to the spreadsheet. So we have all of those parameters put in, our sizes of our buildings, and then we do our heat loss calculations. So in this case, we add up all of the heat losses by taking the area times the U value, and I put the formulas up here as you would also, so that you make reference to them. So if I was to click on this box here, you'll see we have a U value times an area. You can see that area says G9. So if I was to go to G and 9 on the spreadsheet, that would be 704. And then the C30 is that design temperature, and that value is right over here. So that calculates the BTU loss on the worst day when it's 0 degrees outside. And we do that for all of the elements that are in our building, and then add them up to get a total heat loss. And like I say, this isn't comprehensive because we haven't put in the floor load, just to make this experiment or this project a little bit simpler. So we do air change per hour, and there's a little bit of a different calculation there. We'll go through that in more detail. So here's the degree days that we got in. As I said, you'll be able to import a spreadsheet. Looks like I've got the hyperlink here, so you can go ahead and find a different area if you're interested, and download the monthly heating degree days, and then we can actually just sum those up to get the total. And then we can use that total degree day heat loads to come up with how much energy we use in a year. And then we can do a comparison. So the difference between analysis 1 and analysis 2 is nothing more than the substitution of the window's U value. And we get a net savings when we go to the second choice in window, but obviously that costs more. We're also going to learn how to just make some simple pie charts so we can look at the contributions for, in this case, window analysis 1. We can show how in that assembly, the window is accounting for 30% of the losses. When we upgrade the windows, it only accounts for 18% of the losses. These pie charts can be a bit deceiving because actual overall consumption has really gone down. And that can be seen in this little bar chart that we make, which is the original consumption, and then the reduced consumption after we've replaced the windows. So we'll learn how to make some of those kind of visuals. So then the final thing we actually do is a cost justification, and that is we take the energy saved, which is just a subtraction. So we're taking one value from the other, so that is I-15 and subtracting N-15 from it, and that comes as how many BTUs we save. We make a guesstimate of what the fuel cost is, and we do that by using a lookup chart. And we get the value of the savings per year, and then the value of the savings over 10 years. And then that number just gives us a guidepost to look at whether this increase in the quality of windows is worthwhile or not, just from the standpoint of energy savings. So we make a guesstimate about glass cost. I've done that by using, I've looked up at Home Depot the cost of a 3-foot by 4-foot window, and then taken that cost and divided it by 12, because this is 12 square feet, to come up with a cost per square foot, just as an estimate. And then I've taken that number and multiplied that out to look at what the, that's C34 times CM37. So that is the total cost of the window system in the building. So we're taking the unit per square foot and multiplying it by the window area, the number of 96. So that's the total cost of windows. Then I say, what would happen if we were to take that value and buy better windows, the premium window edition? And I'm going to assume that that costs 30% more, so I take 0.3. So I take that number times 0.3, and now the additional cost of our windows is $763. So now we have two numbers: how much we save in 10 years, and how much more we have to spend to save that amount of money every year over 10 years, for a total of $310. So that's an idea of the cost of money. So it would take longer. It would almost take 20 years for the windows to pay back if there was no interest. So this is just a simple analysis. It just gets us a way to relate the change of a R value in a window system with cost, with the amount of energy consumed to do this evaluation. Now down here I've gone ahead and grabbed some charts and put them on the spreadsheet, because we can use this spreadsheet for all kinds of analysis. We can continue to change it or modify it on other projects that we might be involved with. And so down here I've included an R value table of common building materials so that you could reference them and then use them up here in the buildup of your wall and window and floor systems and roof systems. So that's a good starting overview. And the next thing we'll look at is actually getting into the details of creating a Google Docs spreadsheet.